Hello my students, we'll first listen to this song, build a vibe, and then we'll get into the class. I just got this song from Instagram and I fell in love with the song. Some of you may already know the song. I think it's a Japanese or Chinese song maybe. Good energy. My dance moves. Alright. I'm a bad dancer. Yes. Music is so powerful, isn't it? Hit the like if you agree. How long is the song? It's a 2 minutes and 1 second song. Nice. So good. Boom, boom. This is a good move. Nice, huh? Alright. Okay, that's it. Now we'll start our class. Okay, students, so I welcome you all to this channel, Classroom. My name is Benathan Patton, and together we'll learn here. So let's continue with the class. I have already discussed about the physical properties of metals and non-metals in the previous video. Now there has been some delay because I was unable to get time to record those videos. So plus today also I'm having a sore throat. Maybe I'm gonna get some some fever. So please don't mind my noise. My voice also. And then yeah, got myself a brand new haircut. Do you guys like it? So this is the new look of me. So if you like it, hit the like to the comment button. Okay, so let's continue with the lesson now. So chemical properties of metals. So there are four chemical properties of metal that we will study. Okay, so let's continue. Let's start with the first one. The first one is the reaction of metal with oxygen. So first one, reaction. Let me just write it in small. Reaction of metal with oxygen. Now, from my experience, what I have understood is that most students, they find these chemical properties to be a challenge, whereas it's actually easy. So I will show you how to study this. So the first thing that you should do is study the formula. There's a formula, okay? So it's given in the textbook. I'm gonna teach you directly from the textbook, not from any other source. So the formula itself is given in the textbook. So for every chemical reaction, for every reaction of metal with one or the other kind, there's a formula. So the way we learn is we study the formula. You have to remember the formula, okay? So if you remember the formula, it's very easy. So first of all, you have to remember the formula. So like I always say, open your notebook, grab a pen or a pencil and start writing, okay? Because this will serve as a notes for you. So reaction of metal with oxygen. So first of all, the formula, okay? Always formula is here. So let's write the formula. The formula is metal plus, so the metal is reacting with oxygen. So metal plus oxygen. So what will you get? You will get the metal oxide. So you'll be getting the metal oxide. This is the formula. Okay, this is what you have to remember, class. Remember, this is what you have to remember. Okay, just like this, you have to remember 4 such, not much, 4 only. Okay, and it is very easy for you. Okay, so now let's take some examples and solve so that it will be easy for you. So let's take a metal, copper. Let's take one metal, copper. Copper plus oxygen. Okay, copper is a metal. Cu is a symbol of the metal copper. Oxygen O2. Okay, so reaction. So when copper reacts with oxygen, what do you get? You will get copper oxide. This is copper oxide. COPP, copper oxide. C class. It's as per the formula. Any metal with oxygen, you will get, what will you get? You will get the oxide of the metal. So basically it's metal oxide. So this is copper oxide, copper oxide. Alright, it's this easy. Okay, you can try with any metal. You can try with any metal. So let's take one more example. Let's take aluminum. Aluminum plus oxygen. So what will we get? Yes, we will be getting aluminum oxide. So we'll be getting aluminum oxide. What is the formula aluminum oxide? Al2O3. Now this is the challenge, isn't it, students? Isn't it? The challenge is here. How to know that this is the formula of aluminum oxide? Well, if you ask me, you have already been taught this in class 9. In chapter 3, I guess, structure of atom, something like that, okay? I don't remember very well, but you have been taught in class 9. So it's not very difficult, okay? So this is taught in class 9, so you may have to revisit and then learn, okay? If I get time, I'll teach you in some other videos, but today this is how you have to remember. This is aluminum oxide, okay? Aluminum oxide. This is aluminum oxide. Then let's take some more example. Copper taken, aluminum taken. Let's take sodium. The more example we take, the easier we learn. So sodium plus oxygen. Now you can fill up this by yourself. So what will be the product that will write here? The product will be metal oxide, which is, since sodium is a metal, it will be sodium oxide. So Na2O. This is sodium oxide. Nah, easy. See, it's easy, okay? It's easy. Let's take one more metal. I have taken copper, aluminum, sodium. Now let's take potassium. K is potassium, okay? Potassium plus oxygen. So what will we get? We will get again metal oxide. So potassium is the metal, so this will be potassium oxide. What will be the formula for potassium oxide? KO or K2O? It will be K2O. So it will be K2O. See, it's this easy, okay? So this is how metal reacts with oxygen. The first point, okay? The first we are just studying the first one. Now in this very topic, you will have to learn about amphoteric oxides. Okay, so amphoteric oxides. What are amphoteric oxides? So one small topic is there, which is called amphoteric oxides. Amphoteric oxides. This is part of your it's there in the textbook, okay, in the same paragraph as this topic. So what are amphoteric oxides? To understand amphoteric oxides, let me tell you this. See, most of the metal oxides are basic in nature. Remember this, okay? Most of the metal oxides are basic in nature. Remember this one. This is very important. Most of the metal oxides are basic in nature. In chapter 2, you will be studying about acids and bases. So when I take up that lesson, I'll explain to you in detail. But remember, substances are of two types: acids and base. Okay, acids and base. Acids and bases. Okay, so here we are discussing about bases. Okay, bases. So most of the metal oxides are basic in nature. I said most, okay, not all, I said most. Since I said most, there are some metal oxides which may not be basic, or rather which may be both basic as well as acidic. Now such type of metal oxides are called as amphoteric oxides. Okay, let me repeat again. Metal oxides which show both acidic as well as basic nature are called as amphoteric oxides. So that's what we will write here. Amphoteric oxide means metal oxides which shows both acidic as well as basic nature are called amphoteric oxides. So small letter M, amphoteric, amphoteric oxides. I'm definitely gonna get fever. I have a sore throat, so please don't mind. I'm taking medicine, but then it's not helping. And I'm gonna get blocked nose also. So class, amphoteric oxides, metal oxides which shows both acidic as well as basic nature are called as amphoteric oxides. Very, very important, okay class, very, very important. So these are very important notes. So this is it. Remember this also, most of the metal oxides are basic in nature, but there are some metal oxides which shows both acidic as well as basic nature. Such type of metal oxides are called as amphoteric oxides. Alright, so now let me erase this and let's go to the next point. Point number 2, reaction of metal with water. Now we'll do with water. So with water, this is our discussion. This is point number 2. Point number 2, formula metal plus oxygen. Okay, let me just do the shortcut. Metal plus oxygen, done. Metal plus oxygen is done. Metal plus water. So what do we get? Metal plus water will get now in this formula there will be 2. The formula is more. Okay, so metal plus water will get metal oxide plus hydrogen. Then the formula is a little lengthy here. We have another more to go. Let me erase this. These things are done now. Then this metal oxide, you write here metal oxide. Again, it will react with water. I was about to write H₂O, but it is correct only. This is chemistry after all, isn't it? So water will give us metal hydroxide. This is the formula, class. You have to study this formula. For reaction of metal with water, this is the formula. Okay, the metal that we will be taking plus water, which is H₂O, it will give you metal oxide. Okay, you are already familiar with metal oxide. Just now we have just written oxides of copper, sodium, potassium. So it is similar to that only, metal oxide plus hydrogen, H₂. Hydrogen is the gas, okay? Then the same metal oxide will be written here, and then it will be allowed to react with water again, which will give us metal hydroxide, the hydroxide of the metal. Okay, so using this structure, let us do some examples and you will understand better there. So let's take one example. Let's take sodium plus, so the metal is sodium plus water is H₂O. Arrow, what we will get? We will get the oxide of the metal, which will be Na2O. Are you all following, class? Are you all following? Okay. Plus, according to the formula, hydrogen, which is H₂. Yes. Now this same thing will be written here. Okay, this same will be written here. So it will be Na2O plus again with water. So which is H₂O. What will get? You will get the metal hydroxide. So the hydroxide of sodium, which is NaOH. See, easy, isn't it? Not difficult. This is sodium hydroxide. Okay. Next, let's take one more example. Let's say potassium. So K plus same. The metal that I'm taking is potassium. Potassium is the metal here plus water, which is H₂O. arrow, what you'll get? You'll get the metal oxide. So it will be K2O plus, according to the formula, hydrogen, so H2. Okay, now we go to the second line, which is the metal oxide, which is this one, will be written here. So let's write K2O plus, again with water, so H2O, and what you'll get? You'll get the metal hydroxide. So you'll get KOH. Okay, hydroxide means OH. Okay, in the rough you can write OH, hydroxide. Hydroxide is OH. Okay, hydroxide. Important. Okay, everything is important. Okay, everything is important. So K2O plus H2O, you get KOH. KOH. See how easy is that? It is not difficult. Okay, my dear students, it is not difficult. All you have to do is put your interest. If you put your interest, things are much easier. Okay, shall we do one more? Shall we do one more? Okay, let's do one more. So I hope you're writing down the examples. So now we have taken sodium, we have taken potassium. Let's take calcium. Let's take calcium. So calcium plus, according to the formula, water. So H2O. What we'll get? We should be getting the metal oxide. So it will be CaO. CaO plus hydrogen from the formula H2. We are still in the first line only. Now we go to the second line. We take the metal oxide, which is CaO, and we write here CaO. And what do we do? Just follow the formula, plus water, H2O. And what you will get? You should be getting the metal hydroxide. Okay, the metal hydroxide. So you should be getting calcium hydroxide. So now you have to know the formula of calcium hydroxide. So let's write the formula of calcium hydroxide. Calcium hydroxide, Ca, open the bracket, write OH, which is hydroxide. Outside the bracket, you put CaOH2. This is the formula of calcium hydroxide, CaOH2. Alright, so this is the reaction of metal with water. We are done with water. Okay, now in this very topic, what is that? Yes, in this very topic, there's a small topic called alkalis. So alkalis, ALKALIS. So what are alkalis? Okay, it is discussed in this very topic in the textbook. So let me tell you what alkalis are. Now class, pay attention to this. These are all, okay, these are all metal hydroxides. Okay, these are all metal hydroxides. These are the metal hydroxides. These are the metal hydroxides. Okay, these are the metal hydroxides. Now all these are bases. Remember class, hydroxides are bases. Okay, hydroxides are all bases. And interestingly, all of these bases are soluble in water. I repeat, all of these bases, sodium hydroxide soluble in water, potassium hydroxide soluble in water, and calcium hydroxide soluble in water. So these bases are soluble in water. Now it so happens that generally all bases are not soluble in water. Okay, so remember, all bases are not soluble in water, but some bases are soluble in water. So these bases happen to be soluble in water. Such bases which are soluble in water are called as alkalis. Alright, so just let's write it down. So what are alkalis? So alkalis definition: bases which are soluble, underline, soluble in water, are called alkalis. So this is what is mentioned in the textbook in this very topic of reaction of metal with water. So remember, alkalis, very important. Everything is very important, okay, because you have an exam to write. Alright class, so we are done with reaction of metal with water. Now we move to the third, which is reaction of metal with acids. Now let's go to the third point, reaction of metal with acids. So third point, acids. ACIDS, acids. This is the third point, point number 3. Formula, there will be a change in the formula, so Let's change the formula. Now the formula will be only one row. Everything. Let me erase everything. I hope you are taking down notes, class. Alright, metal plus, not water now, metal plus acid. Acid, okay. Now, there are two types of acid. We have got dilute acid and concentrated acid. So what is the difference between dilute acid and concentrated acid? The difference between dilute acid and concentrated acid is in their strength. Remember, concentrated acids are very strong. Okay, they are very strong. Whereas dilute acids are not that strong. Reason because they are mixed with water. They have been diluted with water. So dilute acids are those acids where the concentration of water is more compared to concentrated acids where the amount of water in concentrated acid is very less. Okay, so just remember that dilute acids are those acids which have been thoroughly mixed with water, whereas concentrated acids are those acids where water may not have been mixed or the amount of water is very less in concentrated acids, making concentrated acids very little. And we should not be playing around with concentrated acids. We should not be playing around with dilute acids also, but then concentrated acids though, okay, maaf kar do, okay, maaf kar do. So with acids in the bracket you write dilute. So metal plus acid, okay, this is the dilute acid. This is the dilute acid, TiL, dilute. What you will get? You will get salt. Very important. This is a very important reaction, class. Salt plus what you get? Hydrogen again. So hydrogen. So salt plus hydrogen. बहुत important है. Very important. Important reaction. This is an important reaction of metals. Okay. So shall we discuss with some examples? Yes. Alright, so let's discuss with some examples. So let's write a metal. So let's take aluminium. Al. Aluminium. Does anybody know the atomic number of aluminium? What is the atomic number of aluminium, class? 10, 11, 12. Sodium, 11. Magnesium, 12. Aluminium, 13. Okay, 13. So aluminium plus, so metal is aluminium plus acid. Which acid should I use? I should be using HCl, okay, hydrochloric acid, HCl. So dilute HCl we're using. Then what I will get? I will get salt. So which salt will I be getting? I'll be getting this one, AlCl. I'll be getting this one. Aluminium and chlorine will react together. They'll form a compound called aluminum chloride. So AlCl3 plus, so this is the salt, okay, class, remember, this is the salt that we have to get from the formula. We all got the salt plus hydrogen. Hydrogen is how much? H2. The formula is, the symbol is H2. Okay, this is how the reaction of a metal with dilute acids are taking place. We'll take some more example. So aluminum taken, then let's take magnesium. Magnesium plus the same acid, HCl. So can you work out the product, class? Remember, you will be getting here hydrogen. So try to work out the product. Fill up. What will you get? Yes, MgCl. Hydrogen already here, isn't it? So you will get MgCl, magnesium chloride. So MgCl2. There is 2 here. MgCl2. Okay, this is magnesium chloride. This is the salt which we are supposed to get from the formula. Okay. Shall we take some more example? Okay, aluminum done, magnesium done. Let's take sodium. Sodium plus HCl. Now you fill up these two. Okay, I'll give you 5 seconds. Fill up. 1, 2, 3, 4, 5. So what you'll get? You'll get sodium and Cl. So you'll get sodium chloride, NaCl, plus hydrogen, you get H2. There you go. This is it. Okay, this is it. This is how the reaction of metal with acids. This is what you have to study. So easy, okay, class? Very easy. This is not difficult, okay? This is very easy. Just study like this. Okay, you don't have to worry. Okay, direct, very simple. It's just that you have been afraid of this. Okay, so I know for many students chemistry is a nightmare. Okay, students prefer physics a lot, biology also they prefer, but chemistry though is not. We are scared of chemistry. But then if you know the concepts, the basics of chemistry, chemistry is not to be dreaded or feared. Okay, chemistry is a fun subject. Okay, this is the only subject where you get to experiment. Okay, so a very interesting experimental based branch of science is chemistry. All right, so point number 3 done. Reaction of metal with acids done. Point number 4, reaction of metals with which one? Salts with salt solutions of other metal. That is point number 4. So let's go to the fourth point. Point number 4, reaction of metal with, it's gonna be a long one. Let's just read everything here. The heading itself is quite lengthy here. Excuse me. The weather has also been bad. These days it's raining a lot. Can't wear sweater also. So every day going out with t-shirts is it's taking a toll on my body. So reaction of metal with solution of other metal salts. I hope it's visible. This is the fourth point. Okay, reaction of metals with solution of other metal salts. Solution of other metal salts. This is the fourth point, fourth chemical reaction. This is also the last point. Okay, so the formula, let's write the formula. What is the formula? So formula is metal A plus salt solution of metal B. What you'll get? You get salt solution of metal A. You get salt solution of metal A plus metal B gets separated. Okay, this is the formula. So you will have to remember the formula. If you remember the formula, 99% of the reaction is done. We are just gonna put the suitable metals and get the answer. Okay, that's how easy it is. So let's work out some examples, because with examples it will be very, very clear. But remember, I'm gonna use the same. I'm gonna just be replacing this. Okay, the formula remains the same, the structure remains the same. Just I'm gonna use some real actual metals. Okay, and then get the answer for you. So let's take a metal. Let's take Mg, magnesium. So magnesium is metal A for me. Okay, remember this is a metal A plus salt solution of metal B. So we need a solution of another metal. So which solution should we use? Let's go and use copper sulfate solution. So CuSO4. C plus the metal here is copper. Okay, together is called copper sulfate. This is called copper sulfate. COPPER, copper sulfate. Copper sulfate is a solution of copper. Okay. This is sulfate, a polyatomic ion which is made up of sulfur and oxygen. So this is polyatomic ion. Okay, sulfate. This is the metal copper. This is my metal. Magnesium is the name of this element. Metal. This is my metal A. This is salt solution of metal B, which means this is the salt solution of copper. By the metal B here is copper. Remember. So towards the end, I'm gonna write copper here. So the reaction will take place. Now what will happen? Magnesium, being more reactive than copper, will go and chase away copper. This is called displacement reaction, where the stronger one pushes away the weak one. Okay, so even in the world of elements also, the stronger, okay, will push the weaker one. So the weaker one has to side away. It's not what to do, nah? Law applies everywhere, even in human life, same thing. Okay, because it's happening even in the chemistry also, even in the atoms also, it's like that only. So magnesium plus copper, so magnesium being more reactive will go and displace copper. So magnesium will displace copper. So now magnesium will be found here. So you will see Mg here forming a solution with sulfate. So you will get MgSO4. See, salt solution of metal A. Wasn't our metal A magnesium? Yes, so magnesium is forming a solution, okay, with sulfate, MgSO4. And what will happen to our friend copper? Copper gets displaced. Copper has nowhere to go. Well, actually he has somewhere to go. Where will he go? He will go and occupy the place which magnesium has left behind. So now copper will be alone. So here is our copper, okay, displaced, but then not forgotten. It is here, okay, it has its own place, okay. So this is how it is, okay. Now we'll take some more examples. Magnesium taken, then let's take iron, Fe plus same, okay, copper sulfate solution. Let's use again. So copper sulfate solution, CuSO4. Now you know what will happen. Same story. Iron is more active than copper. Iron displaces copper. Copper will go in. Now copper will be removed. Copper will go and take the place of iron. So copper will be here, and now iron will form a solution with sulfate. See, easy, you know. I hope you understood. Did you understand, class? Yes. Okay, one more example. Okay, let's take one more example. So I've taken magnesium, copper. Let's take our copper. We have been displacing copper. Copper is feeling bad. So let's take copper and let's also make copper happy. All right, let's make copper happy, because the poor copper, okay, was befriending sulfate but chased away by magnesium, was befriending sulfate, again chased away by iron. So now let's make copper happy. So copper plus, to whom will copper displace? Let's use a silver nitrate solution. So AgNO3. This is silver nitrate. Ag is silver, this is nitrate, silver nitrate. So this is the metal and this is the polyatomic ion nitrate. So it so happens that copper can actually displace silver. So copper is very happy. Yay! Okay, now copper will get to displace silver. So copper will go and say go. Okay, now copper will be the boss. Okay, so copper will boss around silver. Silver is weak. So silver can do nothing. So silver has to obey quietly. Yes, I'll go. So silver will go. So silver will go here. So silver is here, Ag. Okay, and copper will form a bond with nitrate. So you get CuNO3. I think it will be CuNO3 Yes, NO3 Finally, copper. This is the time of copper. Copper gets to form a salt solution with, nitrate. Okay, so this is copper nitrate solution. So this is it, my dear students. This is it. This is how you study the chemical properties of metals. Okay, if you ask me, the physical properties are very easy. So many students, they prefer the physical properties, but then even the chemical properties are not hard. Okay, we have just done all the chemical properties given in the textbook, which is part of the syllabus, and I'm sure by now you are also saying, your heart is telling you, your brain is telling you that it was not easy, it was not difficult, it was easy. Okay, so it is this easy. All right, so before I end the video, here's a question. I want you all to comment the answer in the comment box. The question is, in order to bring back the shine of gold ornaments, which reagent or solution is used? Fill in the blanks. You fill up the answer here. So please comment the answer. Okay, the answer to this question is there in the textbook. I will not tell you which page it is, but it is there. Okay, it is there in the textbook. So it is around this topic. It is around this topic only. So just go through the textbook and get the answer to this question and comment the answer in the comment box. So class, thank you so much for joining in and watching. As always, okay, always happy to see you. So if you have not subscribed to the channel, subscribe, okay, and then please forward these videos to your friends, your to anyone you know, okay, your cousins, nephews, family friends, distant friends, okay, to anybody who is in class 10 and whom you feel these videos will be helpful. Okay, so that is my humble request. Please share this video to anyone who you think will be needing it. And then I have met and I'll be making more videos, so I'll be needing your support. So I'll see you again in the next video. Till then, take care and God bless you all.